everyone, and welcome to another exciting episode of our weekly Cloud on Air Innovator Series. I'm Chloe Condon, a cloud advocate here at Google, and I'll be your host each week as we dive into different technical topics, watch demos, and learn best practices from some of our top experts here at Google. If you joined us last week, welcome back. And if you're new here, welcome. We're so excited to have you join us and be a part of our new community. Now, if you're joining us live, you may notice that we have a live chat. So feel free to use this space to interact with other viewers and ask any questions that you may have about the topics being discussed in today's session. One of our moderators will try to answer you live in chat, or you may just be lucky enough to have your question answered live on the air during our question and answer session with our speaker at the end of this presentation. And if you're not joining us live, make sure to register for one of our upcoming sessions so you can join in on the fun live as it happens. To learn more, check out cloudonair.withgoogle.com, and you'll be able to take a look at our previous streams and register for all of the upcoming sessions. And now, I'll pass it over to this week's presenter, Gleb. They'll be teaching us all about building RAG applications with Google's AI-powered databases and showing us how to build your next AI wonder. See you next week.
Thank you very much for the intro. Let's have a little bit fun here. So what I'm going to do, I'm going to start from a short introduction, what we plan to achieve today, and then we are going to continue with all our agenda. Let me open my presentation and then go forward. So that's what we plan to do. We are going through introduction, starting the lab. Then we are going to talk a little bit about what RAG is. Then we are going through the lab step by step, and I will try to explain as much as possible what and why we are doing every of those steps. And then hopefully we have some time for Q&A, and I'm going to explain some other aspects, like where you can also try that application, where can you run that lab, not only in QuickLab or Skill Boost environment, but in other environments as well. So first, I think it is the most difficult part for everybody is to start the lab itself. This is what we are going to start. Here you can see the link to Cloud Skill Boost at Google. So if you would like to start from clicking that link, I hope that you can see that link in the chat right now, or you can request in the chat to provide that link. So you are going to see sign in form. If you have if you registered for the webinar with a Google account, you choose sign in with Google and use that Google account. If you have chosen to use personal account not at gmail.com or google.com, then you have to use the lower form with email and password. If you don't have account on Cloud Skill Boost, you need to click Create Account. Creating account is quite simple. You provide your first, last name, you provide your email, company, and password. And of course, everybody loves CAPTCHA. That's it. You create account, you log it in. And when you log it in, you're going to have dashboard. So on the top left of the Skill Boost, you have a dashboard. If you click dashboard, you should see in progress down in this in the screen our QuickLab. And I will pause here just for a while. I'm going to start it from myself, the same process as you are, and you probably will see. So essentially what you're gonna see is that particular screen, the lab itself, and you have to click on Start Lab button. The lab deployment will take some time. Usually it takes 10, 12 minutes to deploy all the required resources and components of the lab behind the scenes. So during that time, what we are going to do, we are not going to waste that time. We are going to talk what RAG is. Let me start that lab on my side as well to be able to follow all the steps along with you, right? Uh, I can actually see, let me show how I do that. And probably it will help you. All right. So I click sign in on the top right corner, and you can see I have that particular the same screen as you are, folks, and I'm signed in with Google, and I'm using my Google account, personal Google account, to sign into the lab. It takes probably 30 seconds usually to sign in. So here I am, and I'm clicking on dashboard, and it says welcome Gleb. And if I scroll down, you can see that I have in progress webinar, right? So, and I click on that link, and I have the lab here. And if I click on the lab, I have that particular screen as you are. I hope everybody was able to follow up. If you are not able to follow up, just ask in the chat, and probably people will help you on the chat, and or maybe translate the question to me, and I can repeat the some steps if you want it. Let me have a look. All right, so I'm starting the lab. It takes. Oh, I'm not a robot. Yes, I'm not a robot. I'm sorry, guys, but security. Bicycles. Let's choose all the bicycles here. I think I didn't miss any. Yeah. So it says estimated time remaining 13 minutes. So we are not going to waste 13 minutes just standing and looking at the screen, right? What I'm going to do, I'm going to run through some couple of slides and explain from high level how RAG works. Oh my God, what is going on my screen? All right, so what is RAG? And we are not talking about the carpet here. We are talking about retrieval augmented generation. It stands for retrieval augmented generation. What it does, it provides large language model access to some custom data set outside of the training data set it was used for large language model. You probably know that all large language model are trained on huge data set. Sometimes it is whole internet available for that particular large language model. And when it is good to have a huge data set because it provides a model with tons of knowledge and everything else, but probably you have some custom knowledge based, authoritative data, some precise data you want to feed to that particular LLM. And what it does when LLM has access to that particular data set, it improves the output, replacing the generated data by actual factual data pieces, which provides actual response to your question, considering what you have for that particular knowledge base in your domain. So it helps to resolve. The first is response based on out-of-date information. So let me explain. For example, you trained the large language model on data set up to November last year. and that's great. But it doesn't really know what kind of flight flying from San Francisco airport to Denver today. So it knows what kind of flights were flying during that particular time uh, until November last year, for example, but it has no idea what its current schedule is. But it can provide response based on generic knowledge. And that response might be not exactly what you are looking for, because you don't you don't need generic answer when some hypothetical flight can fly from San Francisco airport. You want to know when that particular flight is flying out, right? So that helps to uh, mitigate that problem. Sometimes also you might see when response is completely false uh, and made from thin air when information is not available at all. If you asking, for example, when first large language model application came out, the most fun question was, oh, tell me about myself, and you put your name to the question, and then you are getting a absolutely, sometimes it is close to some reality. If you are a public person, probably if it would be um, uh, President Biden or Justin Trudeau, it would provide actual information, because data set has tons of information about public people. But if you are not so public, it would be completely made up biography with absolutely bogus facts which didn't have place in the past. So that helps RAG to avoid that false response completely made up from thin air. And another thing is, for example, we know schedule for flights, and schedule for flights is more or less stable from season to season, right? And we can say that, all right, we know that flight to Denver, flight 3 times per day from San Francisco airport, usually it is gate C25, D35, and something else, and F1, for example. And that is normal schedule based on multiple years of available for the model. And model can assume that schedule is not changed. Gates are the same, and will provide that generic answer based on that information. Yes, of course, you have flight to Denver. Here are the gates, and that gates will be the gates usually used for that flight. But it doesn't actually mean that today the flight will be flying on that time and from that gates. So how we can make it happen? We can have the database where we place all our information about operational information about the flights. And when LLM request that database, get information about flights to Denver with assigned gates and time when it is coming, flying out, it will increase the response much better. It will be actual factual data in your response. So if we try, let's go to the presentation again and try to uh, go through step by step. It is not exactly how it works. It is high level explanation. So you have a question, and probably it is not the first question to your LLM. It has some kind of history. So you get that question plus history of your questions and answers from LLM. Then, based on that information, you start to generate requests to dataset. And that request to dataset can be done by multiple different ways. In our case, we are using retrieval service, which will be so retrieval service is part of application which stands and provides some kind of API for your LLM application based on path and parameters. In our case, for example, we are requesting flight to Denver. What we are going to provide, I want flight search from San Francisco airport to Denver. Great. Then retrieval service pass that request to the database and return back a JSON, for example, blob with information. Here are the flights, array of flight from San Francisco to Denver with times, gates, and air companies and everything else, all required information. Then combining that query you just posting as a question plus history of responses and questions plus that piece of database, that all the bulk of information put as a question to LLM, and then LLM will analyze all that information and provide the final response, picking up particular flight based on your parameters in the questions, for example, picking up considering the time, place, location, and everything else, and provide it as a final response to the question. And then you might ask, oh, all right, I know the flight is flying from gate C31. Great. And then you can ask another question. And that question is going to the same chain. The question, for example, do I have any coffee shops around the gate? And then you are not really providing the what kind of gate, because you assume in conversation we are talking the flight, we are talking the gate where the flight to Denver is going. So, and that is going through query plus history of conversation, generate request to data set about what kind of coffee shops, what kind of restaurants we have around that particular area in the airport, and then generate that list, feed it back to LLM, and provide the final response. It is how RAG works in the basic high-level overview. There are multiple ways how you can make it even more complicated, more precise, put in some special guardrail and tell for LLM. If you didn't find any flight in the database, don't make it up from thin air and just tell, oh, unfortunately, we don't have any flights available for you. It will prevent people from hallucination in the LLM. So that's the idea, what we are trying to do. We are trying to improve response based on factual information, on authoritative data. So, and what kind of application we are going to use today? Of course, you already heard about, I was talking about flights and San Francisco airport. So we are going to use the simple, it is sample application. It is just for demo purposes. It is, of course, not real San Francisco airport data. We are just using small sample data set in our application to make it working as it is San Francisco airport assistant. But of course, it is not, it doesn't have actual factual information about all amenities in San Francisco airport or all the flights and everything else. It serves only for demo purpose, how it can be done. If we go back, that application is going to run on our Google Cloud Compute Engine machine, and we will have web access to that application. That application will be running using LangChain and LangChain agent for React RAG techniques. So React RAG techniques, that agent will be responsible to call for retrieval service, get factual information from retrieval service, which in its turn is going to run query against AlloyDB database. And AlloyDB database inside will have tables with flights, amenities, airports, and for search, it will be using vector search in AlloyDB. So when you ask question about coffee shop, retrieval service will create a vector for your request and then compare that vector with information about all the restaurants, shops, and everything else in AlloyDB, which has vector. I will show you inside during the building the application how it looks inside the database, and then getting the list of possible point of interest from AlloyDB, it will return it back to your LLM application, and that LLM application will be calling the Gemini Pro model in Vertex AI and generate response back final answer to your application. We're going to all the steps. You will see all those steps executed by the application. All right, so that's was introduction, what RAG is, and what now we are going to do. We are going to start our lab. I hope for most of you, the lab is already provisioned. I can right now see on my screen that it is almost done. It is still showing that provision lab resources, but I already see the link to console. I see already username and password. I'm not sure if we need to wait more, but we probably can try and open it right now. Let me do that right now and see how it works. So what I'm doing, I'm copying the link, open the, oh, it is now. And you see the counter stopping. So we technically we have 1 hour. It is more than enough to run through the lab. So open link in new tab. I would advise to do Skill Boost Labs in incognito window, but here what I'm not using incognito window just because it would be inconvenient for me to switch between screens now and then all the time. So I'm using tabs here. Right, let's password. Let's provide the password for our account. No thanks. I agree. And you can see I'm in Canada. It's great weather outside today. And agree and continue. Great. So the next step is we can see what is advised here. And the next step, let's see what exactly is deployed. First, what we have VM instance with name instance1, and it is deployed in US Central 1 F zone. And we have AlloyDB, AlloyDB cluster deployed in the US Central region as well. And we have IP for AlloyDB cluster. So we are going to use that two resources primarily. And of course, we have Vertex AI on backend, which will be responsible to return and work with us. We are going to use two models for generate vectors and vector based on vector search. We are going to use Geka model, and for LLM, we are going to use Gemini Pro model. It is the latest Google Gemini Pro model available right now in Google Cloud. So we are starting from activating Cloud Shell. Continue. And let's make it a little bit bigger. Right. I hope you can see. I'm not sure if I can increase the font here. Let me check it out. Let me try Control Plus. No, it doesn't work in that mode. No, it doesn't. But I hope you will be able to see. Let me check how it's seen from. Yeah, you should be able to see. So let's go, and what we are doing here is by default, as you can see, it is opened in our project. So I'm not trying to do that. You can list the projects, of course, just to make sure, yes, this project we are going to use, that's great. So what we are going to do, we first, let's set up our default region. It will be just a little bit easier. It is not required, but usually I set it up just to make sure that I'm not going outside of region, because we have deployed all our resources in the same region. And let's say if we're deploying anything else, it will be in the same region. Right. Now, what we need to do, we need to connect to our instance using SSH from the Cloud Shell. And of course, you can connect to that instance from any other SSH client. If you prefer to work from your laptop, that's fine with me, but I'm going to show how to use Cloud Shell for that. And to connect, we're using gcloud command. It asks us to create the pair of secrets and public keys. It is what I'm doing. So just respond Y for yes or no, and then just push button enter a couple of times. It will create a key and connect to the instance eventually. So we are inside. So we are in the instance. And what we need to do now, we need to install the client to work with our AlloyDB database. And it is quite simple. We have a command, you just copy and paste. We are using apt-get update and install Postgres client. Here you can see the commands. So we copy in here and paste in here. And it takes just no time. So we can check the version is 13.13, not the latest one, but it will work for us anyway. So we installed it, and now we can go through the next step. So to connect to the instance, we need to know instance IP, username, and password. The username is default user for Postgres. We are going to use, for simplicity, username Postgres. Of course, nobody is going to use user Postgres in any kind of real application because it is not the right way to do that. But we have already a password. So let's export that password as environment variable in our instance. And we need a couple of more variables to connect to the instance. We need IP and name. So what I'm doing here, I'm getting project ID first, then I'm exporting a region and cluster name. You can see the cluster name here. And then I'm getting instance IP using gcloud command. In reality, I can just put instance IP as 10.8.0.2. And then I'm running command SQL host instance IP user Postgres, and password will be provided implicitly because we exported the default environment variables which can serve as a password, PG password here. Here we are. And you can check what kind of databases you have inside cluster right now. This backslash and L, you can put plus here, will provide the information about the databases. So we have internal service databases, default Postgres database, and a couple of template database, which will be used if you create a new database. So that works really well. And what we are going to do now is we are going to, we closed that connection, as you can see. And now we are going to create a database for our application. And database for our application, it is command executed create database assistance daemon. I'm doing everything from command line. And it is pSQL will connect using instance IP, user Postgres, and run that command, create database assistant demo. And if we go back just a little and run again command, just connect to that environment, in list all our databases, it is \l plus, you can see our database assistance demo here right away. So what we need in that database, you remember when we discussed about RAG application, and I mentioned that we are going to use Gecko model and vector search. So we're going to populate our data set with some data which require vector data type. To enable vector data type in AlloyDB, we need to install create extension. Here's the command, create extension vector. So what we are doing, we just running that command here, and it will create extension inside database. So that extension allows you to not only create a table with data type vector, but also use all the vector pgvector provided properties, like you can use L2 distance for search, you can use similarity for search, and so on. So we did it. Now we have database with enabled vector extension. We need to populate our database with some data. And it is one, before doing that, since in our application, all the components are populated, updated, and working with using the Python, we need to first install proper Python version. We have that old Python version installed by default with our instance, but it is not enough. We need more fresh version because application require version Python of 3.11 plus. So to do so, what we are doing here, we first need to install some packages. And we are using apt install command to install all those packages. It will take some time to download and install packages to the instance, not too much time, but probably a couple of minutes. And it is always an interesting question. Do I need to create my application using the advanced Python version, or stick to old one to reduce friction during deployment application? And that's no easy answer. From my point of view, it is better to install the latest version, which is safe and from some bugs and everything else. And you can use proper libraries, proper dependencies to make your application more like production ready, even when you create it for demo. In my opinion, that's better to use later Python version than by default than use the old version just for simplicity and reduce a little bit of friction, couple of minutes of installation. By the way, most interesting that for me always is the most of the time during installation is taken when you update manuals for the packages, because it is rebuilding the search index inside. You can see that it is processing for ManDB. All right, so packages are installed, but it is not enough. Now let's install pyenv environment. The pyenv, you notice that I copied that particular part and just pasted it, and it would install pyenv. What pyenv does, pyenv allows us to use different Python versions together and switch between them. It is probably the most convenient way to install the proper Python version. But I'm open for any suggestion. How would you do that? You would do that. It would be interesting, actually. So now what we are doing here, we are installing the Python 3.11.6. So what it does, it is getting to python.org, getting that distribution of Python, and then going through installation process, untar, uncompress, going through a process of creating all the files, and then installing it. That installation is going to be local for that particular user. So you're not impacting the entire system by that installation, and you are just using it for yourself only, which is quite convenient for demo and proof of concepts. So let's probably talk a little bit what we are going to achieve the next. You can see the next step will be populate the database. What it does behind the scenes. Behind the scenes, we are using the Python packages to connect to the database and sample data set deployed in with our application. It is small CSV files, and that information will be pushed to the database, and all other metadata will be updated as well. So it will create for us some data which will be used and will look like up-to-date flight information, for example, with flights for today and tomorrow and other days. So that is quite convenient and way for the demo. But of course, in your case, when, for example, you build your own application, it will be quite different. You will have a huge database with your data. Maybe it could be different types of data. It could be operational data for your store. It could be operational data for your knowledge base and anything else. And then you don't need to build it, but you need to properly work with those data. And that will be done through the same process using, in our case, that special retrieval service. So the retrieval service is working with database. Application is working with retrieval service. It is how we architected our sample app. Again, keep in mind that it is not real data. It is just simple data set for demo purposes only. Installing Python, it takes about 3, 4, sometimes even 5 minutes, unfortunately. Maybe if we would have very beefy, big instance, it would take a little bit less time, but I don't believe too much less. It is just CPU intensive part. Almost here, I believe so. And also, what I can open here as another window, you might find it useful, is the application itself. So the application itself, oh, sorry, it is, the application itself is at Google Cloud Platform, Gen AI database retrieval app. It is under Apache 2 license, and everybody is welcome to get application, test, check, and if you find an issue, of course, you can find the issue here. We have absolutely amazing team of engineers behind that application. They were just happy to create something interesting, entertaining, and simple to demonstrate how can be used RAG with LangChain. Right, so we have Python 3.11.6. Great, Python is here. Now we are populating the database. Let's clone that particular application here. So we use git clone for that. And now what we need to do, we need to create configuration file. this configuration file. And that configuration file will be using to connect to our database primarily. It is the main idea. So what we are doing here, we are copying the example config file to config file, and then we are replacing the instance IP from localhost 127.0.0.1 by actual instance IP for our AlloyDB primary instance. Then we replacing the password, username, and database name. So if we run that, we have that configuration file. So it is listening on port on all interfaces on port 8080, and it is going through all that credentials to connect to the database IP address, user, and our password for the database. Great. So now what we need to populate our database. So we installed the Python, but you know, the Python is working with multiple different libraries. So we need to install some requirements. And after installing that requirements, we are running run database init Python script. So let's copy and run it here. It will not take too much time, probably a couple of minutes, maybe even less. That part is not so difficult as installing the Python itself. The Python itself taking time because compiling probably part is taking most of the time behind the scenes. All right. It is installing the collected packages. The package is already downloaded, installed, and now, and probably you can see install among the packages, LangChain community, Google Cloud Storage, and everything else. So everything is installed. Now it is running the Python script to populate the database, right? So done. And I promised to show you some how you can see the database. So let's run the psql. And if we run psql, we have host name, user, DB name here. Yes, psql host instance IP, user Postgres, DB name. And you remember the password we already exported as environment variable. So if we connect here, we can see all the tables. We see 3 tables: airport, amenities, and flights. And if we trying to describe the table, we can put plus here to get a little bit more information. Amenities, you can see that it has name, description, location, terminal, category, hour of works, and everything is inside the vector here, embedding vector. And vector 768, it is default vector size for Gecko model in Vertex AI. Select, for example, name, description, and probably location from limit, let's say, first 3 rows, right? I think, oh, I missed one letter here, right? Yes, and so it is a name, it is description what it is, and where it is located. That information is probably very useful when you try to find something around the gates, right? So great, let's move forward. And we initiated the database. Now we need to deploy extension service. So to deploy extension service, we need to create a service account for that extension service. So what I'm doing here, I'm put the plus here, and it will open another tab in my Cloud Shell. And in the new tab, I'm creating a new service account. So it runs gcloud em create retrieval identity service account. And then I'm providing that account with a role AI platform user, which allows that service account to make a call to Vertex AI. Done. The service account created. We don't need that tab right now. Let's exit from the tab. And now it will take some time for us to deploy Cloud Run, probably about 4 minutes for deployment. So you can just copy and paste. It is using network default, region US Central, service account, our newly created account, and you see the parameter no allow unauthenticated. It means it will not allow any non-authenticated user to run any query to that service, which is good from security point of view. Right. And you probably noticed that we switched to directory app. We switched to root directory of our application. So we were working in retrieval service directory here, running that run database init Python script. And then we switched to here. And we switch here because how we defined our directory for retrieval service. And probably it is much better to just define the directory and with slash, and then that Cloud Run will create a container based on that path. So it is going to find the Docker file here, create the container for Cloud Run, put it to container repository, and then build it that container there, and then create revision and enable the endpoint to be able to connect to that working app. So you probably know the Cloud Run is Google Cloud Container Service. So it is everything is uploaded. It is building container right now. It will take probably a little bit more time. The container is built. Now it is creating the service itself. So you have a container. Now you have to deploy that container in Cloud Run service. So that takes some time to allocate that pod, put it container, and so on. So it is not too much time, but the beauty is if you create it once, you can create revisions relatively quickly after that if you want to change something and build a new container. So it works really well. And by the end of the creation, what it has to provide, the endpoint URL. We can go and probably switch to Cloud Run here. You can see it. Yes, it is building right now. And hopefully it will be ready really soon. I'm not sure if we will have enough time for Q&A, but I have a colleague behind the scenes, and if you have a question, you can post your question in the chat, and they will try to answer as much as possible to those questions. I know it is sometimes quite boring to see the screen when something is deployed and you cannot have a control on it. You cannot increase the speed or do anything else, but it is done. And for example, what I was telling that if you try to curl from that API endpoint, if you are not authenticated, you are getting 403 error. You are not authenticated, access forbidden. So how we do that? We are using curl, with token. And for token, we're using gcloud auth print identity token. So we're using a header for the curl request, authorization, barrier, and token. And then Here I am providing that gcloud command just to return the same exactly endpoint. And it should provide hello world, of course. Yes, it does. We can see hello world here. So our service works fine. What we are going to do the next? Oh, I'm sorry, guys. I didn't see the chat update about increasing the size. I looked on my screen and it was looking fine. How can I increase it? Let me check. I'm sorry. The three dots on the top of the browser. No, it is not the here. Zoom. Okay, let me. I hope it is better now. I'm sorry, I didn't see in time that update in the chat. All right, so again, we using. Let me. Am I still here? Yes. So we are using authorization bearer cloud identity token, and we are getting proper response. So now we can actually move to application side. The retrieval service is done. It is working. It is open for requests. But now we go and run application. So to running the application, we switch to Launchchain Tools demo directory. Yes, we're switching here. And installing some a little bit additional packages that related only for application itself. So they are not required for the idea for retrieval service, but for application you have to install them. So next, what we are doing is we exporting base URL. Let me make it a little bit bigger as well. Probably like, yeah, okay. We exporting the base URL here and then running the Python main py. Base URL, it is the same URL it is for our identity service because applications should know where to call it. So let's do that. And we should see output here. And it is running on all interfaces on the port 8081. So if you try to connect, of course, you are getting error because that doesn't translate to anything. But how we can connect here is we are creating a new tab here. And we are using SSH tunnel. So we are connecting to the same instance and translating port 8080 on our shell to port 8081 on that instance. So it is quite simple command. Here the parameter -nl 8080 colon localhost 8081. So, and it means when we run it, we were able to use web preview in our shell to port 8080. If you see the error bind 8080 cannot assign requested address, that's all right. Don't pay attention to that. It is expected because that interface is not what we are going to use. So, and then we are using web preview on the port 8080 here. And here we go. We have airport assistant. So you can put any question here and see, for example, hi, how can you help me? And it answer, I can help to find your way around the airport. Let me make it bigger as well. All right. But flights and recommended amenities. So that's great. And if we have a look to backend, we don't see too much in our terminal. I'm switching to the first tab where we run our application. It doesn't provide output. How to get information, how it works behind the scenes. Let's stop application. I'm doing Control C to stop application. And then I'm exporting the environment variable debug. Debug true, and just start an application again, Python main py. So what it does, it is open that internal logic of application for you to see how it works behind the scenes. So I'm going to assistant here and asking, when is the, or are there any flights to Denver? Oh, 3 flights to Denver. And if you have a look on your application, you can see all the logic behind the scenes. So the first is human. Are there any flights to Denver? And it will use action list flights, and it will put from context default departure airport, arrival airport, and date. And it will use that retrieval service to get information from the database about available flights. And 3 flights match in that query, and it is information given by retrieval service. So that information plus question is passed to LLM, and then finish it chain, final answer, yes, there are 3 flights to Denver today. Would you like me to list them? Let's try. Yes, please. And it is giving me information from gate, flights, and time for first 2 flights. And you can see all the logic here based on previously available information. So I can ask another question about, for example, are there any coffee? Oh, sorry. Around the gates are 40. And it will provide you answer, but more interesting how it does it, right? So let's go down and human. Are there any human? It's me, just for clarity. Are there any coffee around the gates R40? And then it will use another tool endpoint on the retrieval service to get that information. And it is running query coffee near gate R40. But what it does behind the scenes, using that information, it creates a vector, and then vector search in AlloyDB, providing the output for information about amenities for that particular request. And then it will enter LLM chain based on all information, and using previous conversation history here, human question, list of observation, and then provide the final answer. There are 5 coffee shops near gate, Green Bean Coffee, and all other. So it is how it works. So on that, probably we will complete our demo and lab. Of course, you can run the lab. Lab is 21 minutes, and again, the lab will be open until Friday morning, so you can try it in leisure time. And in meanwhile, if we have time, I will be happy to answer any questions. So, guys. All right. All right. Let me see what we have as a questions. Okay. Copy link address. All right, no questions. Okay, if no questions, we can wrap up on that. And be free to send me a message, email. You can find me on LinkedIn and X, former Twitter, and I'm open for any conversation and follow up. Thank you very much, guys. It was a pleasure to present you today. I hope you liked it. Cheers.
At Google Cloud Next, we're announcing an amazing show.
All right, cue the music.
We're building the new way to cloud.
So that just means we get to think even bigger.
And now helping you connect like never before.
Let's start with development.
I'm loving this. Super cool.
AI is going to change the game for all of us.
Live on the demo stage.
I can't tell you how excited I am to continue blowing people's minds.
We're now in the midst of one of the most profound technology shifts in history. There's so much more for all of us to explore together that'll power this next chapter of digital transformation.